Hi, my name is Jason Shim, and welcome to Arduino Classics. Today I'll be presenting to you a dice simulation with LEDs. So when a button is pressed, a random number between 1 and 6 will be called, and the corresponding number of LEDs will be lit up. There will be an animation showing the dice being rolled. It looks like this. As you can see, pressing the button causes the dice to re-roll, and a random value is displayed after that roll. So, what exactly do you need to make this? Well, here are the materials. Quick note, all of these come with a kit that we recommend. Link in the description. We will need one Arduino Uno, 6 generic LEDs, they can be any color, one push button switch, 12mm, 10 jumper wires, 6 220 ohm resistors, and one 1000 ohm resistor. Now this is what the project schematic looks like. I will be going back over on how to build this, but feel free to refer to this at any time in the video. Now, without further ado, let's get to the building. I start by placing down each of the 6 LEDs. Along with them, I place a 220 volt resistor along with a wire connecting it to one of the pins on the Arduino. The LED's cathode will be connected to the resistor, while the LED's anode will be connected to the pins. I will repeat this around 6 more times, so I will speed it up for your viewing pleasure. Next, to make it a complete circuit, I will connect both ends of the circuit with jumper wires to the GND and the 5 volt pins respectively. GND to negative and 5 volt to positive. After that, I will want to set up the button as our main source of input. The button is important because it lets us essentially control the flow of electricity as a switch. It lets us turn things on and off with a binary input. In this case, we will set up the button by connecting it to the 12 pin, along with connecting the 1000 ohm resistor to it. And with that, we have finished creating the build. Now all we need to do is input the code and upload it to see if it works. We'll start by initializing all of our pins. So I'll call them 1st, 2nd, 3rd, 4th, 5th, and 6th. So 1st is 2, 2nd to 3, and we'll also want to initialize our button switch, pin, and a binary value to check the state of the button switch, since it only has 2 possible inputs. Int button to pin 12, and int pressed, which we'll leave at 0 for right now, which stands for false. Now we'll have the setup to do. So I'll start with the for loop in order to set all the LED pins to output. And I'll create a variable just for the sake of it. It's a throwaway variable for the for loop. And so essentially what this does is set all of the pins to outputs. We've done this in previous classes, but this is our first time using a systematic for loop for it. So the second part, it sets a condition at which the for loop will stop. In this case, it's if our variable I, which we set to the first pin, reaches the value of the sixth pin. And this is what happened. This is the increment after this is successfully executed. Now we'll also want to set the button pin to input since we didn't cover that in the for loop. So pin mode button input in all caps. And so we're also going to want to initialize our random seed by noise from analog pin 0 since we're creating a die and we want it to be truly random. I'm not going to go into too much depth, but we're going to want to have this. Okay, we are pretty much done with our setup. Now we're going to want to create a function called animation. And this is going to be our animation. It's going to light the LEDs from left to right and back to build up tension while waiting for the dice to be thrown. And let's get into this. So again, we're going to want to create a for loop. And this time we're going to want to nest an if function. And we're going to want to put delay on it so it doesn't go too fast. I'll make it like 100, but you can put anything, it's an arbitrary number. So this is the function for left to right. We're also going to want to create something right to left. I'll just copy and paste that. And we're going to want to replace some values to make it coherent and not the same thing as the other one. Instead of incrementing it, we're going to want to subtract one from it each round. And yeah, by this point it's just substitution and making sure that everything adds up to what we want it to do. We're going to keep the delay at 100 because it would be odd if it went left to right and right to left at different speeds. And we're done with that. Now we're going to create a method to show the number, because we have our method for the function for the animation, but we don't have one for actually showing the random number that's generated. So we're going to want to call the digital write function. And it's going to continue like this. Oh, I forgot the variable there. but yeah, so I could use a for loop for this. And we're going to change the values. And that is done. Now we'll need this, and our setup here previously, this, we're going to use it for this integer that we're going to return, and this gets a random number in the range 1 to 6. So int, oh whoops, didn't indent correctly. Int rand number equals random from 1 to 7. And it's 1 to 7 because normally indexing in computers, it doesn't start from 0. So 1 would be the first value instead of 0, and thus forth, which is why 7 is, which is why we're using 7, which is 1 more than 6. And after calling that, we're going to return the value to throw dice. So we're also going to need another function for setting all the LEDs to the int value. And for this, we're also going to use a for loop for int I equals first, I is less than or greater than to 6, I incremented. And we're going to use digital write once more. Value. And so now we're going to make use of the loop. Oh wait. I don't believe we finished this. Yeah, sorry about that. So yeah, now we're going to have our main method, our loop, where everything we've set up so far will be executed. So press equals digital read button. And so this ensures that if the button is pressed, the dice is cast. And so this removes the previous number that was randomly generated. So it's re-rolled. So set all LEDs, which is the function we created earlier, to low. We call the animation. And after that, we are done. Let's see if... oh, whoops. Oh, yeah, I forgot this. I misspelled it. So, there's that. I bet this is also an underscore error. This too. Yeah, this is why consistency is important. And I believe this should work. So let's test this. After plugging the entire circuit into my computer, I found out that it did indeed work. However, if yours doesn't work, you can email us about any potential problems you have, and we'll try to troubleshoot them. Thanks, and see you next time.